Alright, in this video here we're going to talk about the domain of a function and how to calculate or how to find the domain of a function. Now, I did a video a while back about finding the domain of an algebraic expression, and the things we do here are going to be basically the same things we did in that video. So if you haven't seen that one yet, you might want to go look at that, the domain of an algebraic expression, where we looked at rational expressions and square root expressions and how to find the domain of those special types of expressions. Like I said, the examples we're going to do here are basically the same type of thing, except now, instead of talking about the domain of an expression, we're talking about the domain of a function. All right, so the domain of a function is the domain of the algebraic expression that defines the function, unless otherwise stated. And you will see sometimes, especially when you're doing word problems, sometimes it'll tell you, the domain of this function is just from 0 to 100. Or the domain of this function is from 0 to 10, or from 50 to 500, or something like that. And it happens in word problems a lot, because a lot of times in word problems, there are certain values that it doesn't really make sense to plug into a function, right? Like if I have a function where like my variable is t, which represents the time since I threw something up in the air, and my function is how high that thing is until it hits the ground, well, in that case, it wouldn't make sense to use like negative t values, because that would be like negative time before I even threw this thing in the air, and it doesn't make much sense to talk about the function of something flying through the air before you actually throw it, right? So in some cases, when you're doing a problem, it will tell you explicitly what the domain is, right? If it doesn't tell you explicitly what the domain is, then you just assume that the domain of the function is the domain of the algebraic expression that makes up the function. All right, so again, if you have not seen the video that I did on the domain of algebraic expressions, you can check that out. But this one is going to basically cover the same stuff. Also, if you didn't see the video that I did where we defined what the domain of a function is, there's a video that I did about the definition of a function and the domain and the range of a function. But just real quick, basically, what the domain of a function is the set of all input values for the function, the numbers that I'm allowed to plug into the function in order to get an output from the function. All right, so for this first one here, f of x equals 1 over x squared minus x. Right, and again, this goes back to the things I talked about on another video for the domain of a rational expression. Well, for a rational expression, there is a certain number that I'm not allowed to have in my denominator, and that's 0. Right? I can never have 0 in the denominator of a fraction, so anytime my function involves variables in the denominator, well, there's going to be probably some numbers that are not in the domain of that function, because some numbers that I plug in here for x are going to make that denominator equal 0. Right? So anytime you have a rational function like this, where you have variables in the denominator, the way you find the domain of the function is to take that denominator, in this case x squared minus x, and say that that cannot equal 0. Right? I'm not allowed to have that denominator equal 0. Can't have it. All right? So now I have to solve for x and figure out, well, what values of x would actually make this equal 0? Well, I have a quadratic expression here, right? X squared minus x. And if you haven't seen the videos that I did about solving quadratics, you might want to review those. But to solve a quadratic, I can use a quadratic formula. I can factor it. And this one I can factor, right? X squared minus x, they have a common factor of x. So I can pull out that common factor of x, which leaves me with, inside the parentheses, x minus 1. All right, and again, I did a video about factoring common factors, so you can go check that one out too if this doesn't make sense to you. So x times x minus 1 is not equal to 0. And then, just like when I'm factoring something that equals 0, I kind of set these apart. So I say x cannot equal 0, and I say x minus 1 cannot equal 0, which when I add 1 to the other side, I get x cannot equal positive 1. Right, so those are the two numbers that cannot be in the domain of this function, because, and if you can go back and check, if I plug in x equals 0 here, I get 1 over 0 squared minus 0, which is going to equal 1 over 0, and I can't have 0 in the denominator. Or if I try to plug in x equals 1, well, in that denominator, 1 squared minus 1, that's 1 minus 1, which equals 0, and I can't have 0 in the denominator. So these are the two numbers that I'm not allowed to have in that denominator of 1 over x squared minus x. All right? Any other real number will be fine, right? I can plug in any other number for x, positive numbers, negative numbers, decimals, fractions, doesn't matter. I won't get a 0 in the denominator unless I use a 0 or a 1. So the domain is every real number except these two. All right, these are the only two that break this function and make it not work and make it not give me a result. All right, so there's a couple ways I can write this, right? I can say that the domain of the function is the set of all x values such that x is not equal to 0, x is not equal to 1. Right, so it's all the x values except for 0 and 1. The way I usually write these is in interval notation, right? It's all the values from negative infinity to 0, and then all the values between 0 and 1, and then all the numbers between 1 and infinity. Right, so this is how I generally give the domain of a function in interval notation, which makes a lot more sense. Well, for me, it makes a lot more sense than trying to use this, set builder notation that they call it. So it's everything from negative infinity to 0, not 0, right? I'm skipping over the 0. That's why the zeros get the parentheses there. All the numbers in between 0 and 1, right? I could plug in 1/2 or 0.7 or whatever. Skipping over the 1 because 1 is not included, so I have the parentheses on the 1, and then all the numbers from 1 to infinity. All right, so it's basically everything from negative infinity to positive infinity, just skipping over 0 and skipping over 1. All right, so that's the domain of this function up here. All right, so that's how we find the domain of a rational function, whatever the denominator is, not equal to 0, and then solve for x from there. All right, and then x can be any real number except for those ones that make the denominator equal 0. All right, I'm going to have to erase some of this stuff because I need some space now to do the next one. All right, so my next one, g of x equals the square root of 9 minus x. Right, so the two types of expressions, the two types of functions where we have to do something special to find the domain is the rational expressions where the denominator cannot equal 0, and then also square root functions or square root expressions, right? Because I'm not allowed to take the square root of a negative number. Right, so whatever's underneath the square root, in this case the 9 minus x, has to be greater than or equal to 0. Right, so both of these special things that I do for domains involve 0. Right, for the rational functions, it's the denominator not equal to 0. For square roots, it's greater than or equal to 0. It's whatever's underneath that square root greater than or equal to 0. Right, so sometimes people get confused. Well, they both involve 0, so I don't remember which one's not equal to and which one's greater than or equal to. But just think about what you're doing. If you have a fraction, that cannot equal 0. That denominator cannot equal 0, so that's where you put not equal to 0. Right, when you have a square root, it can equal 0. It cannot be negative, so that's where you get greater than or equal to 0. Right, not less than 0, which would be a negative number. Right, so if you get confused with that, just pause for a moment and think about it. Well, what numbers can I have in the square root? I can have 0. I can have positive numbers. I can't have negative numbers. That means I use the greater than or equal to. All right, so 9 minus x is greater than or equal to 0. And now I have to solve this inequality for x. So let me subtract 9 on both sides. I get negative x is greater than or equal to negative 9. But then I have to divide by this negative 1 to make it just be x. So I get positive x is less than or equal to positive 9. Right? Little thing with inequalities, which I don't think I made a video about this, but something hopefully you remember from learning about this stuff in the past. Anytime you're solving an inequality and you multiply or divide by a negative number, you have to flip that inequality symbol. In this case, it changes from greater than or equal to less than or equal to when I divide by that negative 1. Right? You can add and subtract negative numbers, that's fine, but anytime you multiply or divide by a negative, it switches that inequality. So we get x is less than or equal to 9. Right? So for the set builder notation, I could say, the set of all x values such that x is less than or equal to 9. And that's the answer there. If I want to use the interval notation, which again, I usually prefer to do, so less than or equal to 9 is starting from negative infinity, going up to 9, and I put a bracket on the 9 because I can include 9, right? X can equal 9, and so it's everything from negative infinity up to and including 9. Right? And if you don't remember the interval notation, I did make a video also on interval notation and when to use parentheses and brackets and what all that stuff means. So you can check out that video to see how that works. So that's how we have the domain written, is using the interval notation. Right? If you want to double check just to make sure that you did it correctly, well, if I plug in a number between negative infinity and 9, let's say I plug in 1. Right? Well, 9 minus 1, that's going to equal 8, and I can do the square root of 8, right? Because 8 is a positive number. What if I plug in a number bigger than 9? What if I plug in 10? Well, 9 minus 10 would give me negative 1, and I can't do the square root of negative 1, so it's good that this stops at 9, because if I try to use a number bigger than 9, I'm not allowed to take that square root of a negative. All right, so you can check these out after you find the domain, especially these ones that involve the inequalities, just to make sure you're on the right side of the inequality. I want the numbers between negative infinity and 9. I don't want the numbers that are bigger than 9. All right, so that's when we have a square root in our function. To get the domain, whatever's underneath that square root is greater than or equal to 0, and then we solve the inequality from there. All right, once again, I'm going to have to erase this so we can do this last one here, where we have h of t equals t over the square root of t plus 1. All right, so this one actually combines both of these last two. There's a square root there, right? But there's also a fraction, and that square root is in the denominator of the fraction. So since we have a square root, normally what I would do is, just like what I did up here, I take whatever's underneath that square root, t plus 1, and say that that's greater than or equal to 0. Same thing I did here, 9 minus x greater than or equal to 0. Whatever's under the square root, greater than or equal to 0. But since that square root is in the denominator, when it's in the denominator, it cannot equal 0, which means I need to take that equal to sign away, and I just have t plus 1 is greater than 0, right? Not equal to 0 this time. Again, because it's in the denominator, it can't equal 0. Right? So this is like one of the tricky type of domain problems where they kind of throw both of the rules together into one single function. Square root, and it's in the denominator. In that case, it's just greater than 0, not greater than or equal to. Right? But then to solve this one, it's actually the easiest one up here to solve. Right? If I have t plus 1 is greater than 0, all I have to do is subtract 1 on both sides, and I get t is greater than negative 1. Right, so for the set builder notation, it's the set of all t values such that t is greater than negative 1, or in interval notation, it's parentheses negative 1 comma infinity. Right, starting at negative 1, parentheses on the negative 1 because I cannot equal negative 1, but then every number bigger than negative 1 up to infinity. Right, so any number in this interval I can plug in for t, and I'll be allowed to, or I will get a result from the function, right? I can put, 0, 1, 2, 3, negative 1/2, any number bigger than negative 1, I can plug in here and do the calculation and it's going to be okay. If I try to plug in a number less than negative 1 or negative 1 itself, something's going to go wrong here. If I plug in negative 1 itself, I end up with a 0 in the denominator. If I plug in like a negative 2 or a negative 3, I end up with a square root of a negative, which I also cannot have. All right, so again, the domain is the set of all numbers that you're allowed to plug into a function. Right, so for this function here, for this h of t function, I can only plug in numbers that are bigger than negative 1. All right, for this g of x function here, I can only plug in numbers, that were less than 9. And for this one, I can plug in any number except for 0 and 1. Right, so it's important to know the domains of the functions you're working on for a lot of reasons. One is just being aware of what numbers work and what numbers don't work. But then also when you're using these functions to solve different types of problems, like it would be important to know, this function only works if we're using numbers bigger than negative 1. It's not going to work for anything else besides that. All right. So again, that's the domain of a function. Very similar to the video I did on the domain of an algebraic expression. Right. For rational functions, the denominator cannot equal 0. For square roots, whatever's underneath the square root has to be greater than or equal to 0. Those are the basic rules that you need for domain of a function. Remember, if you have a polynomial function where it's just 3x to the 5th power minus 7x squared plus 2, the domain of that is going to be all real numbers. Right? If it doesn't have the fraction, if it doesn't have the square root, generally then the domain is all real numbers. Although there are some functions that are exceptions to that, which you'll learn like in higher levels of algebra and precalculus and stuff like that. Like some of the trig functions, some of the logarithmic functions have different domains, but you'll get to those later on. All right.